Welcome. I hope you find this webinar interesting and relevant. We certainly believe at NEBSYST that this topic is relevant, especially in these unprecedented times we are living. However, at the very least, I hope you will find the webinar enjoyable. I will do several demonstrations, live demonstrations during the presentation, so don't worry because it won't just be a long and boring talk. Now, when we talk about online labs, we usually refer to two different kinds of laboratories, virtual and remote. Let's do a very short introduction to what virtual and remote laboratories are. And first, we will introduce the virtual ones. Virtual laboratories are computer applications, usually web applications, but they could also be native or desktop apps that run a simulation with a mathematical model that represents the system. Therefore, there are two main parts in a virtual laboratory. The first one is the view, what the users see and interact with, and the other part is the model. One possibility is that the model is run locally in the same device the virtual lab application is running. That's the example represented here in this slide. However, it is also possible to have a model of the system running in a different device, in a computer, in a lab, for example. This usually happens when the simulation is heavy to load and run, or when the provider of the simulation wants to monetize its use or control the access and the use of the simulations, or protect the source code of the model. So in general, virtual labs are computer applications that have a user interface and a mathematical model, and both interact to deliver an experience with which users can do practical work. The mathematical model can be implemented in any language, of course, MATLAB, LabVIEW, Python, or whatever. And the same happens with the user interface, which can be written in HTML5 when they are web applications, or in any other language or many other languages when they are native and desktop applications. Now let's talk about remote labs. What is different in a remote laboratory? Well, basically what changes is that instead of having a mathematical model that simulates an experiment, a plant, a system, or whatever, we have real laboratory equipment that is ready to do things in the real world. In this case, the hardware is of course placed at a different location than the remote lab user interface or application runs at. But again, we need some program that controls the hardware, operates the actuator, takes measurements from the sensors, and so on. This software can also be implemented in a variety of languages, such as MATLAB, LabVIEW, Arduino, or many others. And the hardware itself, of course, also changes a lot from one laboratory to another. And with that, we come to the first demonstration of the webinar. It is a very short one to illustrate with real examples what virtual and remote labs are. So now let me switch the presentation to my desktop to show you a couple of lab applications. Okay, so let me close these windows, and now we are ready to go for the first demonstration. I'm going to start with the virtual laboratory, but first, as you can see, I have two folders here ready for this first demonstration of the webinar. I'm going to show the same plant, the same experimenter system, which is a Furuta inverted pendulum. And I'm going to show two implementations of this laboratory. First, the virtual laboratory, and second, the remote laboratory. So if I enter in the first example in the virtual laboratory, what I have basically is an HTML5 that has been created with one of the tools that you can use with our system, with Enlarge. And as I said, this basically creates an HTML5. It's an HTML5 application that you can then embed in any web page, so you can use it for educational purposes. For example, if I run this file, then I get this simulation here. Right now, the pendulum is in a stable position. For that reason, it's not moving. I can rotate the camera. It is a 3D model. And basically, I'm going to explain this because the Fruta pendulum is the example I'm going to use almost through all the webinars, so I need to explain it a little bit. So there are two important angles here. The alpha angle, which controls the inclination of the stick of the pendulum. So if I introduce a perturbation there, I move it, and now the system is controlled, so it goes up again. And also I can change the beta, which is the angle to which the motor is looking at. Also, I have the beta reference indicated here just with the label reference, which allows me to move the position to which the motor is looking at. So if I move this to the right, you can see that green arrow moving in the representation, and the pendulum follows that angle. So that's called the beta reference because it is a reference for the beta angle. As you can see, when I set 1 to the reference, the beta angle goes to 1. If I set 0.54 to the reference, the beta angle goes to that value. Okay, now let's see the example of the remote laboratory. I have entered the folder with that example, and I have exactly the same, an HTML file. If I double click on it, now I am connecting to the real hardware, to the laboratory in this case in UNED. I must say this is a laboratory that it is located 30 kilometers away from where I am recording this webinar. And in this case, what we have is a more simple user interface. We can only control the period, we can ignore that, but again, the reference controlling the beta angle. So if I move the slider again to the right, you can see the pendulum moves to the right, the beta angle follows the reference, right? So those are two quite simple, but I think nice examples of virtual and remote laboratories. Now I'm going back to the presentation. There we go. A few seconds till it loads. Okay, there we have it. And we can move to the next slide. So now that we have at least a general idea on what virtual and remote labs are, I can talk about the process of developing labs. For this, let's first discuss the workflow we'll usually follow when preparing a new traditional hands-on lab for our STEM students, me included, because I am also a university teacher. The first thing you do when preparing a new laboratory practice is, of course, selecting the system or experiment you want your students to work with, or you, or your colleagues, if it is for research. The second step is to study and understand the system as well as you can. And the third one is designing the experiments you want to be performed with the system, either as laboratory practices or as research activities. Finally, with all that in mind, you can finally buy, build, or prepare, however, your experimental setup in the lab. But if you want to have a virtual laboratory, then you need to do all these things and one more step, which is developing the computer application of the laboratory. I wrote there in the slide web application because in NEBSYST we focus on web solutions due to their advantages in accessibility. Moreover, in case you want to have a remote laboratory, not only the web application is needed, but you also need to enable the remote operation of the experimental system in your lab. Of course, this is also the case of virtual laboratories that use simulations that run on a server. Finally, both for virtual and remote laboratories, you need to deploy the web application into an e-learning platform where you can make it accessible for your students and use it for educational purposes. So there are 3 additional, and why not say painful and time-consuming steps that you need to go through when developing an online laboratory. In Nebulous Systems, we believe this is the real reason behind the fact that online labs are not more popular. Not because they are not useful, interesting, challenging, or educational enough, but because they are hard to develop and sometimes to maintain. Actually, there are many research works out there that have studied the learning outcomes of students when using online labs, either alone or in combination with hands-on laboratories, and there is a consensus that results are as good as when they use hands-on labs only, at least as good. So that's why Nebulous System was born and Enlarge was created for, to help you to easily develop, manage, and deploy online labs so you can offer them to your students or you can use them for research activities. And for this, we offer you our company's services and products. Regarding the products, let's start with the products. We have the Enlarge system, which includes everything you need for this. This system allows you to connect to any computer or physical system that is connected to your university private network from anywhere, from any point of the internet. These connections are done safely, orderly, in a controlled way, and can even be collaborative. This makes them ideal for use in educational and research experiences with lab equipment. With Enlarge, you can also assign profiles with different privileges. Think on students or lab technicians, teachers, IT staff. They all have different needs for the use they could do of the system of online laboratories. Another important thing is that no installation of software is required in the devices that are made accessible. You don't even have to configure anything in them. This is a network solution. The system is compatible with the most common software tools in education and research, for example, MATLAB, LabVIEW, or Python, C, and so on, as well as with any hardware device that can be controlled with a computer system, including commercial lab systems from different brands. The system connects with any e-learning platform or learning management system that supports a standard called LTI, which basically means that any e-learning platform or LMS is compatible with the solutions. Enlarge gives also a set of solutions so you can design, create, deploy, and use labs the way you want, the way you need it. So it is sort of a do-it-yourself kit for this. But Enlarge also assists you in doing all these tasks as easy and as fast as possible. Regarding the services, Nebulous Systems can help you in different ways. 1. Before you decide to acquire any of our solutions, we will help you deciding which ones are best for you, depending on your needs and your budget. 2. We install all the hardware required in your university and tackle any problem it may arise with your IT department. This hardware either comes with our software already installed or we can install it on site. Once you have acquired the system and everything is installed and running, we take care of updating and maintaining it. We also provide training to teachers, IT, and technicians in both face-to-face and at distance. For example, we have an online course with manuals, videos, and everything you need to start using our solutions. We will see that in the second demonstration of the webinar. Finally, if you don't want or you don't have time to develop and deploy the online labs yourself, we can make this for you. In these cases, we work in collaboration with the university and its teachers to develop the web apps, the lab control programs, and integrate the online labs in the e-learning platform to maximize their educational efficiency. So now let's give an extremely quick look to the online course and training materials we make available to anyone who acquires our solutions. So again, I'm going to switch to share my screen. There we go. And now I'm going to enter the e-learning platform and the online courses that we have in Nebulous Systems. So there are two courses, demonstrations, we will go to that one later on the webinar, and the course for learning how to use our solutions. So here basically what we have is a forum for doubts, also a chat, some useful links, and also some text describing the structure of the course, which is basically divided in 4 sections. We are going through 3 of them in the webinar, the 3 last of them, developing laboratory web applications, a little bit about developing laboratory control programs and making the hardware and software reachable, and the last one, integration of lab web applications into a learning management system. If I click in any of these sections, for example, the second one, we have all the material there. You can find documents with PDFs here with all the information you need to start using our solutions, and you also have video tutorials that have English subtitles to help you go through all the required steps. So let's go back to the presentation. Okay. So let's go back to the 3 additional steps that you need to address when preparing an online laboratory. In the rest of the presentation, I will go through these 3 steps, explaining one by one how Nebulous Systems and Enlarge can help you facing each of them. Also, every time I finish presenting our solutions in each of these steps, I'll do a short demonstration. We start with the part of developing the web application for your online laboratory. The idea here is to be able to create web lab applications that look nice, offer all the experimentation possibilities you and your students may need, and to do all this as easy and as quick as possible. This is an example of a virtual lab of a servo motor created with one of the tools that you could use with Enlarge, the same tool that I use for creating the virtual and the remote labs examples I showed you in the first demonstration. Here in this example, everything has been created with such tool. The graphs, the sliders, the buttons, and the input fields. The good thing is you can do all this yourself almost without having to write any code. Not even for defining the mathematical model of the system you are simulating. As easier as this can be, and believe me, it can be quite easy, you may still feel like doing this would be very time consuming. Or maybe you may feel like this is a very closed application where students do not have much liberty because, they just need to enter values in the input fields, move the controls, the sliders, press buttons, and watch data in graphs and so on. For these cases, our solutions offer a different type of approach that, 1, make the process of creating the web application even more simple and fast, and 2, provides a more sandbox type of laboratory with a higher degree of interaction. In this case, Now we have a remote lab example instead of a virtual lab example. The graph here at the top right of the image is not built by the web lab developer. Instead, it is the user of the lab who defines it, typically the student. You can see this piece of code down here. That's how a user would define a plot of a new graph, in this case by programming with blocks. This way it is the user, the student usually, and not the web laboratory designer, the one who decides which data he or she wants to be represented. This part down here also allows a higher and more open degree of interaction with the lab through a code editor. As you can see, the application in this example does not have as many controls as the previous one. This is because everything is controlled from down here, from the code editor. Also, it is important to highlight that this code editor can be either visual, like in this example, with a block programming language similar to Scratch, or it could be textual, accepting many different types of programming languages such as JavaScript or MATLAB. Even better, the graph builder and the code editor appear automatically, and their connection to the web application is also done automatically. So this means zero effort for the lab developer here. But of course, we will understand all this better if we see a live demonstration on how it works, right? We'll get to the part of the graph builder and the code editor and their interaction with the online labs, but for the moment, let me show you an example on how easy it can be to build a web laboratory interface, or at least part of it. So again, I'm going to switch to share my screen. There we go. And now what I'm going to do is to open the tool I have mentioned before that you could use to create virtual and remote laboratories that are compatible and supported with the enlarged system. I have already opened the application, the web application for the Furuta pendulum, the remote laboratory of the Furuta pendulum, but it is incomplete. If I run this application, clicking in the run button here, I will see that, oh, not there, sorry. Okay, give me a second. I just need to tell the system to run this with the browser so we can, yeah, there it is. So we can see how it looks in the web browser, just like we did before in the first demonstration. Now again, if I click on the run button, you can see I do not have the video streaming feedback from the laboratory, and I am also missing the blue slider that was here for controlling the reference on the beta angle. So these are two components that are missing in the web application at this moment, and I'm going to show you how easy it is to add them, to create them. So for the first part, for adding the video streaming, I'm going to add this element here, cam image, and I'm going to place it here in the draw panel. I'm going to call this element webcam to be more clear. And the only thing I have to do is to double click on the element and tell this element, configure it, and tell it that I want to connect to the video stream. So for that, I'm going to link this field to a variable that I already have defined with the URL to the video streaming. This URL is given and made accessible thanks to the enlarged system, which we are using underneath. So I click there, and that's all for getting a video stream. Now I'm going to add the missing control, the slider for Okay, there was a problem with the audio there. I think it's back, so I'm going to repeat. Now I'm going to add the control that was missing, the slider for controlling the beta angle in the Furuta pendulum. So I select the element, which is this one, slider. I put it here, and then I double click on the element to edit it, and I need to link the value of this control to the lab control variable that controls the reference of the beta angle, which in this case is this one called beta ref, if you remember from the first demonstration example. I click there, and now I'm going to fill also these three fields here. I'm going to enter the minimum value this control can take. So this is an angle in radians, so I'm going to set the range from -pi to pi. So in JavaScript, you write that like this, and the maximum would be pi. And then the step, I would set that to 0.01. Again, this is in radians, so in degrees that's about 0.5 degrees. I can click on save, and then if I run this application, what we will see now is exactly the same application I showed in the first demonstration for the remote laboratory of the Furuta pendulum. I click on run. Oh, I forgot to do a small change. I need to enable this. I don't want to enter in the technical details there, but this is basically enabling the communications through the enlarged system. Okay, so if I click on run now, I get the communication established. I receive video feedback from the lab, and the missing slider, blue slider down here, that allows me to change the variable in the lab, in this case the angle to which I want to move the pendulum, is also working. As you can see, there is communication between my web application and the laboratory 30 kilometers from here. Okay, let's go back to the presentation once again. So I hope at this point I have convinced you on how easy the first part can be, the part of developing the web application of an online laboratory. If so, then I can move to other of the three additional steps that we need to address when creating an online laboratory. I will leave the second one for the end, as it is probably the more difficult to explain. I need more time to explain it. And therefore, I will talk now about the part of developing the online lab. Also, in the demonstration at the end of this point, I will show you the part of the graph builder and the code editor I mentioned a few slides before. So you will have a demonstration on how that works too before you have time to forget about it. So when we think in an online educational scenario, a general one, we usually have in mind something like this. First, we have students who can be at their homes, at work, in the university's computer room, but also at the metro, the bus, or whatever with mobile devices. Be it as it may, the general idea is that students can access an e-learning platform or learning management system where they have the online courses of the subjects they study. Here they find all the typical educational resources and activities such as documents, forums for doubts, videos, quizzes, or tools to deliver an assignment. This space is supervised by a teacher or several teachers who keep track of the students' progress. They can also assign grades to them for certain activities. They may also answer doubts in the forum and so on. But what we are talking now about is to also give them access to virtual laboratories in this very same online course. This way, students do not have to visit external web pages or download native apps. They find all the required learning resources in the university's institutional platform. We believe that having everything just in one place makes it more convenient for them, for your students, and saves them time and frustration because they do not have to go to different places and download different things and log into different web pages and so on to get all the learning resources. They have all of them in one place in the online course. So, and there is another additional advantage, which is that teachers can track the students' progress in the lab activities that are embedded in the online course. They can also grade them, or they can enable or disable their access, and so on. Of course, Enlarge supports adding remote laboratories to your online courses too. In this case, as we mentioned at the beginning, real hardware from a laboratory must be connected to and used. In this whole scenario, we can identify 4 roles. We have already talked about the first 2 of them, students and teachers, but 2 new roles appear with the addition of online labs. The lab web app designer and the remote lab owner or provider, if you prefer. Sometimes the teacher, designer, and provider is the same person, but sometimes it is not. For example, a lab technician in your university could be the one who developed the online lab, being both the app designer and the lab provider, while you are the teacher that manages the learning of students and grades them. Or it could be that you prefer us, Nebulous Systems, to be the app designers of your online labs. Finally, it is very important to say that Enlarge users, Enlarge customers, automatically join the Enlarge Federation. Now, members of the Enlarge Federation can share their online labs among themselves in any terms they may agree on, for free or for a cost, for a limited number of hours per week, and so on. So in these cases, it could also be that you, as a teacher in your online course, you have a remote lab that has been designed by yourself, but other remote lab in your online course could be from a different user of the Enlarge Federation. And in that case, a different person, different user of the Enlarge Federation would be the virtual or remote lab app designer and the remote lab provider. And now it's time for a demonstration again. Now we are going to see how easy it is to deploy an online lab into an e-learning platform. So once again, I'm sharing my screen. I'm going to minimize this because I do not need it anymore. And I'm going to this course here that I prepared for the demonstration for this webinar, for the deployment demonstration. So first thing I'm going to do is to turn editing on. Well, let me do a little bit more of zoom here. Like this is fine. I'm going to turn editing on. This is what any teacher would do in its e-learning platform from his or her institution to add a new resource or learning activity. I'm going to click here in the Add an Activity or Resource button. I choose this tool that we provide in Nebulous Systems to integrate remote or virtual laboratories in online courses. And I need to do 3 things. First, I need to enter a name for the activity. Let's call that Remote Lab Furuda Pendulum. The second thing I need to do is to add here the remote laboratory, the file that has the remote laboratory, the HTML file created by the tool I shown in the previous demonstration. This one we just worked with. For that, first I'm going to disable this page so this code is not executed, and then I'm going to package this application. Instead of run it like I did in the previous demonstration. I'm going to package it into a zip file that contains all the required files. I give it this name, remota.zip. I click on yes to replace the older file. There it is. So now if I go to the folder where this file is generated, it is this one. As you can see, it is 14th of April, just the same date, and it is also the same hour. 14:12, it's 14:13 now. So if I drag and drop this file that we just generated here, I have completed the second step, and I just need to do the last one. I need to tell the system that this is a remote lab and not a virtual lab. So I need to tell the system that yes, this is a remote experimental system, and then I need to select which of the experiences, which of these already defined remote lab experiences this one belongs to. As you can see, we have several ones here developed, but in this case it is this one, the fruta pendulum, in Spanish péndulo fruta. If I click on save and display, then you can see I have my remote lab already embedded in my online course, working the same way that we saw in the previous demonstration and also in the first demonstration, but now it is embedded in an e-learning platform. I can still use it the same way, and it works. Now, remember I also told you that I was going to show you how the code editor and graph builder were automatically integrated and automatically connected to any virtual or remote lab you add in your online courses with our tools. So for that, I'm going to go back to the form where I can edit settings for this lab activity, and I'm going to this section here to configure the code editor and the graph builder. I tell the system that I do want to use the code editor and that I do want to use the graph builder. Sorry, this is in Spanish, but basically what is saying here, this label is show blocks for graphs. So now if I click on save and display again, just by doing this, now you can see we have connection to the remote lab, and it is exactly the same, but a few buttons have appeared here at the bottom: experiments, data and charts, run and log. So now what I'm going to do is to create a new experiment. I click here, I give it a name. I'm going to leave the default one, and I have the code editor. In this case, with the programming language based on blocks. What I'm going to do is to go to the execution menu at the left, and what I'm going to do is to say that I want to start the lab in this experiment. I also want to start data collection for plotting data in a graph, and I'm going to move the pendulum by setting a value to the beta ref variable we have also mentioned in previous demonstrations. So what I'm going to do now is to assign a value to that variable, for example 0.3 radians. So when we execute this experiment, we will see the value in this field here go to 0.3, and the pendulum would move to that position. And now we are going to define a new graph. I click on new chart script, and here I go to data and charts, drag and drop this block, and this allows me to define a new graph. As you can see here, it says create chart. I'm going to plot angle versus time, so I give it that name. So in my x-axis I would have time, and in my y-axis I would have the angle. These are the labels that would appear in the graph, but now I need to add the variables to be plotted. So I drag and drop this block, and in the x-axis I want the time, And in the y-axis, I'm going to plot the alpha angle, for example. So now when I run this, you can see the pendulum has moved to 0.3, just like I told him to do, right? And I have my graph, which is representing the alpha angle. It is a very small variation in the alpha angle because it is kept almost vertically. You know, when I move it, it destabilizes a little bit, and we can see it moving a little bit more. Right, so we go back to the presentation once again. And now we are reaching the end of the webinar because we have finally come to the last of the 3 steps, which is the part of enabling the remote operation of your system. But this is still a bit far from the end, actually, because this final step is divided in 3 new steps. Anyway, these are the 3 things that you need to take care of in order to enable the remote operation of a system that you want to use as a remote lab. First is what we name the experiment connectivity. The requirement for being able to operate an experiment remotely in terms of connectivity is that such experiment can be automated and controlled through any type of computer system. Whether it is a single board computer, a PLC, a personal computer, anything is valid within large. For this, basically, you need the required set of digital or analog actuators and sensors. The second is the experiment autonomy. Here, the idea is that the lab could operate without supervision. For this, you need to assure that devices are powered on and off when users connect and disconnect from the lab. And another important aspect is that many systems and experiments should be able to reboot to an initial state after a user disconnects or before a new user connects. It is not a requirement for all type of experiments or system, but it is fairly common. And finally, third is the experiment accessibility. Even if you have built your web application and you have deployed it into a learning management system, just like we saw in previous demonstrations, that app must be able to connect to the hardware in your lab, right? Not only that, you may want to control the access somehow, whether this is with a queue system, with a first in, first served policy, or with a booking system that allows users to reserve time slots for working with the lab. Now, before going into more details in these 3 issues, let's talk a little bit about the architecture for remote laboratories. Similarly to a previous diagram I showed before, we have our end users at the left, typically students, but could also be teachers or researchers. Here in the middle, we have 3 servers. The one at the bottom is the enlarged MyFrontier system, which is what NEBSYST would install in your institution to make all this possible. Then we have the enlarged MyIntegration server, which basically offers the functionality for integrating the web lab applications so they can be shared with your institutional e-learning platform or any other learning management system, just like we saw in the last demonstration. And the last server, the CMS, LMS, EMS consumer, at the top represents exactly that, your institutional e-learning platform or any other learning management system. If your university uses Moodle, then the MyIntegration server can be integrated with your institutional server, making everything cheaper and, saving costs. Similarly, the MyFrontier server could be installed in any server in your institution, which is also cheaper, of course. Finally, on the right part of this diagram, we have a possible solution for a remote laboratory setup in a real laboratory. In this case, we have a personal computer with a USB camera controlling an experimental system. This one in particular is a commercial setup by Quanser. The software that controls the equipment could be in LabVIEW, in MATLAB, or who knows what, right? With Enlarge, it hardly matters. But of course, there are more possible configurations. How about this one? Using low-cost solutions such as Arduino instead of computers, or using IP cameras instead of USB cameras because it is easier for providing video streaming. And also using a custom experimental setup built at the university instead of using a commercial setup. Well, don't worry, this is also supported by Enlarge. And what if you want to use a single board computer such as Raspberry Pi or Red Pitaya and a different commercial setup from a different manufacturer? The one in this example is from Piwe. We'll do it, no problem at all. And what if I want to use a PLC, a programmable logic controller? Well, I didn't represent that here, but that makes no difference with Enlarge. You could do that too. But there is still something missing. Remember I mentioned something about automatically powering on and off the equipment upon users' connections and disconnections? How do we do that? Well, for that, the Enlarged system is capable of automatically operating what we call the MyPDU units. These units can be either from a third party, such as this one from APC, or they could be ours, assembled and manufactured by Nebulous Systems. In any case, the Enlarged system will take care of communicating with these devices, these PDUs, so that the devices you connect to them turn on and off when a user starts and stops using the lab, respectively. And you may still be thinking, whoa, this still looks like a lot of difficult work. Well, if you think like that, we still have one more surprise, the Enlarge MyConvergence. This is a device that allows you, 1, to have the MyPDU functionality integrated in one single device, 2, connect a USB camera to have video streaming through a server that comes already pre-installed and ready to run with the Enlarged system, and 3, connect a wide variety of hardware thanks to its Arduino connections and support. You can extend its inputs and outputs with more Arduino boards. Also, remember that 1, you would have Nebulous System support and materials to learn how to connect and configure things, and 2, you can always hire Nebulous System services to develop lab control programs, web lab applications, and so on. So at this point, you might still be thinking, wow, installing that MyFrontier server in my institution would mean so much trouble. I think I'll pass. Well, we have thought of that too. Nebulous Systems offers a cloud solution that is ideal for those institutions that are just looking for an entry point to start doing online labs with the minimum required cost and installation. Indeed, this solution does not require the installation of the MyFrontier hardware or software in your institution at all. For this, instead of using MyConvergence devices, we provide a very similar IoT device, in this case called MyGateway, which enables the communications with your labs through our own cloud service. As I mentioned, in terms of costs, this solution is the best for those institutions that are going to have a reduced number of laboratories, like 4, 3, or less. For larger installations, however, I would definitely recommend the previous one. And there is even more. We can make things even simpler for you if you want by also offering the My Integration module as a cloud service. This way, as this diagram represents now, we only have here your institutional platform, the MyGateway devices, and your lab equipment. Now let's go back to the three issues with the tasks of enabling the remote operation of your system to sum all this. First one was the experiment's connectivity. As we have seen, there are many hardware and software solutions. Most of them are perfectly valid, of course, and the use of one or the other just depends on the budget or on personal expertise or on personal preferences. That's why we designed a system that supports any type of hardware and software you may be using or you may want to use in your lab. Not only that, we manufacture and provide our own lab equipment called MyConvergence to make your life easier when preparing your system for being remotely used. Finally, a second product called MyGateway allows your institution to solve the whole problem with cloud solutions that make things even easier and are more cost-effective for small installations. The second one was the experiment autonomy. There are three things to have into account here. One, as an institution that provides online labs to your students or to other institutions, you want to make sure your labs are operative as much as possible. These labs, that's the second point, these labs may need to be able to reset themselves to an initial position or state. And finally, it is important to only power the equipment when they are in use to avoid damaging them, and also to avoid wasting energy and money. Now, Enlarge offers solutions for each of these three problems. For the first one, the system notifies the teachers or the lab technicians when labs are down through emails and notifications that are sent automatically. For the second one, Enlarge notifies the lab control program when a user disconnects, so measures can be taken in the lab, in the lab control program in the lab to reset the lab. You can take measures to automatically reset the lab. And for the last one, for the last problem, Enlarge turns on and off the power automatically when users connect and disconnect. And finally, the last part when enabling the remote operation of a system was the experiment accessibility. For this, you need your lab as a web service so that any web application can communicate with it. To this end, Enlarge supports and integrates web protocols. Also, there are many learning management systems out there, and each institution may have a different e-learning platform in which they want to integrate their online labs as a fundamental part of their online courses. So that's why the Enlarge web applications called MyUIs can be deployed into any learning management system. And finally, the My Integrations module includes solutions to control the access to the labs either through queues or through a booking system. And we have come to the last demonstration of the webinar. Here I will show you a couple more of remote laboratories that use different hardware to demonstrate a wide range of connectivity uses. I was also going to show how labs are automatically powered on and off, but you have already seen that several times when I was connecting to the remote lab of the Fruta pendulum, when lights were flashing on when I connected to the lab. That's the Enlarged system controlling the powering of things, of lights, of the power supply units, and so on. And finally, I will also show how the access to a remote lab is controlled with a booking system for the part of accessibility. So for the last time, I'm going to share my screen. Okay, sorry again with the sound, but I'm back. So now what I'm going to do is to enter the second course, demonstrations. And I'm going to show you two different remote labs. First one is about the Wheatstone Bridge. So this is an example of a remote laboratory with a circuit. So we have two cameras here. One is the general experimental setup, this one at the right, and the other one is a view from this black camera that is placed over this mover, over the ruler, so that students can see the position they are placed at. The idea here is to close this circuit here and to measure the resistance of this wire. So you can close the circuit either with wires or with resistances. I'm going to do it with resistances. I'm going to choose these three resistances here, and then you can either choose to connect them in series or in parallel. I'm going to choose series. And once you have finished setting up the configuration of the experiment, you click on continue. You turn on measurements and you start getting measurements here. Right now the measurement is compensated, but I can move this mover over the ruler. You can see it moving. And the idea is that students need to get the measurement to 0. And when they do that, by taking the measure of the distance of the position and multiplying that by the resistivity factor, which is a known value, they can obtain the resistance of the wire. So that's the first example. That was a custom setup for a remote laboratory and not a commercial one like the first demonstration. And I'm going to show another example more for showing the wide applications in connectivity terms. But first, I am also going to show you that if I try to access this lab here, which is controlled through the booking system instead of with a queue system, then the e-learning platform is not going to allow me to access the application because I do not have a booking made for today and for this hour just yet. So if I try to access it, as you can see, I have a measure. Sorry, it is in Spanish, but basically what this says is that you do not have a booking for this lab in this hour. Check your active bookings in the booking system. So the previous lab allowed me to enter because it was configured in open access, which uses a queue system. And since there was no one using the lab, so the queue was empty, I was able to enter the laboratory. But this one is controlled, is configured to be used with the booking system. So I need to first go here to the booking system. And what I'm going to do is to choose the servo motor remote laboratory. And then I need to choose the date. This one is the right one. We are April 14. And it's 2:30, a little bit more. So this is the time slot I want to book for the lab. I click on book. I get my booking here. By the way, again, this is in Spanish. Sorry about that. But the application is also in English. It is important to say that this is also in English. I just forgot to configure it. So now I have my booking, and that means that I should be able to click on the servo motor application activity and enter. Yeah, you saw that. You saw the lights flashing again. That's the enlarged system once again controlling power. And now I am able to move the motor to different positions and do any kind of experience that this lab is designed for. I can go out of the laboratory and then everything turns off, all lights, all power, and so on. So once again, for the last time, back to the presentation. There we go. So now just one last word about enlarge. What I wanted to say is that due to marketing reasons, we are changing the name of the system from enlarge to NEBSYST. So don't be strange if you go to our webpage in maybe a couple of weeks or 1 month or whatever, and you see the name change and you do not find any reference to enlarge. Instead, references are made to NEBSYST and the logo is also changed. Thank you, and I hope you enjoyed this webinar.